That's the rostral part of the cranial cavity, and there's the caudal part. We see the tentorium cerebelli, osseous as well as membranous part, separating the cerebellum from the cerebrum. Here we also have some meningeal layers present. At this point, we can see the venous sinus present all the way along the dorsal midline. Now this dorsal sagittal sinus. Remember we spoke about sinuses which are present in the dura mater. This is one of them. So as we come to the caudal aspect, as we come to the tentorium cerebelli, we see another sinus which has been transected along its transverse plane. That's going to be present on sides, and that is your transverse sinus. Both of these sinuses are going to be connecting each other, and so they play a major role in drainage of the blood from the brain as well as drainage of the cerebrospinal fluid from the subarachnoid space. What I'm going to do now, I'm going to lift up the membranous structure which is placed between two cerebral hemispheres. As I go little deeper, okay, and that membrane which separates the cerebral hemispheres from each other, this is extension of the dura mater, and that is your falx cerebri. The structure or extension of the dura mater which separates the cerebral hemispheres from each other. Along with this falx cerebri, on the top of falx cerebri, you see the sagittal sinus or median sagittal sinus located right on top there. At this point, we see the pituitary gland closely associated with the hypothalamus. If you look at divisions of the brain with respect to the cranial cavity, we have the forebrain, we have the midbrain right here, and we have the hindbrain right here. This is cut section through the thalamus, showing the cavity with thalamus from each side. As they are connected to each other, that forms the interthalamic adhesion, and the space surrounding that interthalamic adhesion is your third ventricle. We look at some of the other features as we look at the brain specimen itself. We're going to use the sheep brain specimen instead of dog brain. Okay, now a few things that we need to realize before we go into the actual structures. The way I am holding the brain, I am looking at it from its ventral view. That's the caudal end, which is spinal cord, continuing from the medulla oblongata of the brain. It is continued further into the neural canal. That's your spinal cord. Caudal to rostral, we can see the structures like that is all your medulla oblongata. We have two raised areas on both sides of the midline. That's the midline right there. And on both sides of the midline, we have those raised lines or raised areas. Those are the pyramids. Now coming to the rostral end of the pyramid, we see some fibers which will be running transversely and forming some sort of elevation right here. That is called trapezoid body. Then from trapezoid body, we have the fibers running more laterally. Those are the acoustic stria. Those are the fibers related to the acoustic, or we can say hearing also. Then as we go further rostrally, so these are the pons each side, the ventral midline. So we look at the pons, still part of the brain stem. Then as we go further rostrally, we can now see the cerebral peduncles, crura cerebri or cerebral peduncles. The structure which is located right below that, I am saying below as we are now holding the brain upside down, that is the pituitary gland. As I lift up the pituitary gland, as I reflect that structure, you will see parts of the thalamus located right here, or parts of the diencephalon. Let's be more specific, parts of the diencephalon. The structure right here is the mammillary body. In front of that, we see the infundibulum, as well as we see the part of the pituitary gland which is connected to the infundibulum, or that is the infundibulum connected to the ventral aspect of the diencephalon. Now here we see the cavity, which is continuation of the third ventricle. If I put the probe in there, I'm actually going into the third ventricle. Okay, so let's put this thing back, and then we continue further to the more rostral part of the brain. Okay, going more rostrally, we have the optic chiasm. The crossing over of the optic nerves is going to take place here. Going further rostrally, now we have the rostralmost point where the optic nerves are coming into the brain, forming the olfactory bulb. From olfactory bulb, we see the olfactory tract going backward, and further we have the piriform lobe of the brain, which is present on the ventral aspect on both sides of the brain stem. Now, lifting up the pituitary gland, if I go right behind the optic chiasm, and if I go further backward, all of that is going to be your brain stem. But then, in the brain stem, you are going to exclude the cerebellum. So, part of the diencephalon, part of the mesencephalon, the pons, medulla oblongata, all of those comprise the brain stem. Okay, now turning it and looking at it from the dorsal view, the optic chiasm is broken, so I need to hold it by the pin. Turning it on the dorsal aspect, we see the major divisions again. The cerebral hemisphere on one side, cerebral hemisphere on the other side. The raised areas, those are the gyri, singularly gyrus. Between the gyri, you see the grooves, sulcus. Then we have that dorsal midline where the cerebral hemispheres are separated from each other. The cruciate sulcus, which is going to be present at the cranial or rostral end. The sulcus, which is fairly constant in most of the species. Coming back, we see the transverse septum, which is going to separate the cerebellum from the cerebrum. So we have cerebellum located here, lateral hemisphere on this side, lateral hemisphere on the other side, the vermis in the middle. All of these are parts of the cerebellum. Now looking at the individual components of the brain, let's start looking at the brain stem. Okay, so this is the isolated brain stem right here. That's the rostral end, that's the caudal end. This is continuation of the spinal. From this point, it is continued as a spinal cord. The medulla oblongata, the pons, the midbrain, and the diencephalon. Remember, these are the parts which form the brain stem. As we are looking at the medial view of that sagittal section, we can see all of these segments are being transected or those being cut along their medial plane. So we have major component of the diencephalon. What are those parts? What is the major structure which are present in the diencephalon? We have the thalamus, epithalamus. Thalamus would serve like it would be further divided into metathalamus as well as subthalamus, and then we have the hypothalamus. Looking at those structures, hypothalamus is going to be located right here, and then we have the pituitary gland closely associated with the hypothalamus. Then the structure that we see right here is basically the thalamus, and so thalamus from each side connected to each other. As that part is cut, this is called interthalamic adhesion, where the thalamus from each side are connected to each other. Then coming backward, we have the midbrain. This cavity right here is your mesencephalic aqueduct, which is going to connect, mesencephalic aqueduct from rostral to caudal end, which is going to connect the third ventricle, which is present around the interthalamic adhesion, to the fourth ventricle, which is present below the cerebellum. So, the part above the aqueduct is your tectum, and the part below the aqueduct is your tegmentum and ventral tegmentum. Coming backward, and we have the pons, and we have the medulla oblongata. Okay, let's leave that structure and then look at the lateral view of the brainstem. Now I'm turning it around to show the lateral view. Now the orientation would change slightly. The rostral end, the caudal end. Looking at the medulla oblongata as well as pons, we see this part which is cerebellum as it was attached to the brainstem or remaining parts of the brainstem. So these are the cerebellar peduncles. Remember, we have three of them: the rostral, middle, and caudal. We don't need to differentiate them at this point, but know that all three of them are going to be located in that region. Coming more rostrally, now we come to the midbrain. Inside, that is the midbrain, that's the raised area. We look at these two structures: the colliculi, the rostral colliculus, and the caudal colliculus. Rostral being located more rostrally, the caudal one being located more caudally. As we go further, more rostrally, now we start seeing the structures associated with the diencephalon. Specifically associated with the metathalamus, we have the lateral geniculate body, slightly caudal and more medial, more inside, that is your medial geniculate body. Okay, let me just turn it around so we can see that clearly. That's your medial geniculate body, and that is the lateral geniculate body. These specimens, as we pin them and leave them for your reference, you can actually look at those things and try to see them with closer view or closer look, so we can differentiate those structures from each other if it is not like very clearly visible on the camera or on the screen. Okay, now let's move on to the next section. We are now going to look at the median sagittal section of the brain. At this point, so at this point what we see is the cerebral hemisphere, the brainstem, as well as the cerebellum. Let's start from the rostral and we'll move on to the caudal end. Rostrally we see the cerebral hemispheres. They are connected to each other. Remember, we discussed about the commissural fibers, the fibers which run from one cerebral hemisphere to the other cerebral hemisphere. And by doing so, they are also connecting cerebral hemispheres to each other. And so, by doing so, it forms the structure which is called corpus callosum. Structure extends right from the rostral to the caudal end. That structure here is the corpus callosum, which is responsible for connecting the cerebral hemispheres to each other. We see the section which has passed through the corpus callosum. So the structure will be present on one side and going to the other side. Right below the corpus callosum, we see another structure which is part of the archipallium, that is the fornix. Now I am rolling the probe along the fornix. The fornix is going to go further around the thalamus, or let's say diencephalon, and then it will reach all the way down to the mammillary bodies. Okay? So the structure below that is the fornix, structure above is the corpus callosum. Now if I try to pull those two structures from each other, you will see like there is this septum which is present between those. That septum is called septum pellucidum, which is going to separate the lateral ventricles from each other. So the septum that we see right here, if I try to break through that septum, I am going to reach the lateral ventricle on that side. Okay? So that is your septum pellucidum separating the lateral ventricles from each other. We'll look into that structure as we look at the other side where we have opened the lateral ventricle. Now, rest of the structures again same. We see the interthalamic adhesion. Around the interthalamic adhesion, we see the space, that is the third ventricle. The third ventricle, then it is continued by the mesencephalic aqueduct, which is the cavity of the midbrain, and then it will be continued further backward into the fourth ventricle, which is the cavity of the hindbrain. That is the cerebellum, that is the middle oblongata. We have the space between them. It has like the membrane extending from the cerebellum towards the midbrain as well as going backward towards the spinal cord. Those are usually called rostral and caudal medullary villi or velum, which actually forms the roof of the fourth ventricle. Okay, so let's look at the other half of the brain or other half of the cerebral hemisphere. Now going to the other half of the cerebral hemisphere, now as we're looking at the other side, the directions would change. Rostral and caudal. We see the cerebellum with arbor vitae, cerebellum looks like a tree. So that is the white matter of the cerebellum, and then around that we have the grey matter of the cerebellum. Coming slightly forward, we have the midbrain again with the mesencephalic aqueduct as a cavity. Then we have the diencephalon, interthalamic adhesion. Coming further forward or more rostral, we have the cerebral hemisphere with corpus callosum and the fornix. Now, at this point, as the section is slightly more on this side, the septum pellucidum was left on the other half, while the lateral ventricle is completely exposed in this particular specimen. Now, the probe is into the lateral ventricle. If you can see it clearly, or otherwise you can look at this specimen and then identify that structure. There is a plexus present inside the lateral ventricle. That is your choroid plexus. Remember, these choroid plexuses are going to be present in certain ventricles which are responsible for formation of cerebrospinal fluid. So cerebrospinal fluid is formed by the choroid plexuses which are present within the ventricles of the brain. Okay, so these are the major structures that we see on this side. Now, remember we spoke about the three different parts of the cerebellum, or three different areas depending upon their presence in the brain in the phase of evolution also. The neopallium, paleopallium and the archipallium. The fornix that we indicated earlier, which is going to further extend to the mammillary body, that is part of the archipallium. So what are the other structures associated with the archipallium? Along with the fornix, we have the cingulate as well as supracallosal gyrus. Those are gyrus, that is also part of the archipallium. Other part or other important structure associated with the archipallium is the hippocampus. In the next section, we are going to look at the hippocampus. For that purpose, we use the brain of the dog. We tried harvesting one from pathology, and now here we have removed part of the cerebrum. Both of those hemispheres are held together in order to perform some comparison to understand what part of the cerebrum is being removed. Okay, so most of the dorsal part of the cerebrum was removed, and so we exposed the archipallium. Specifically at this point, we see like this structure right here. It has like two holes because we had the brains inside here. That structure is the hippocampus. It starts rostrally, then comes backward, then again starts going more rostrally. So that is the hippocampus. Closely associated with the hippocampus is the fornix. The fornix then is going to go further. We can see the fornix in the sagittal section of the brain. Okay, so these two components are components of the archipallium. Going more rostrally, this is part of the cerebral hemisphere which harbors or which actually contains the caudate nucleus. The white matter of the cerebrum, the grey matter of the cerebrum, grey matter located outside, white matter located inside. But remember, when we look at the transverse sections of this cerebrum, at one point we saw the structure called internal capsule. Internal capsule is a mixture of grey and white matter, and on both sides of the internal capsule we have the basal nuclei located in the cerebrum. So let's look at that particular place where the internal capsule can be seen. Now the next section, what we did, we actually cut the brain into two different ways. For the caudal 2/3 of the brain, we took the sagittal section, and for rostral 1/3, we have the transverse section. And so what we see in this transverse section, white matter, white matter, white matter. Okay, one thing to mention about the white matter of the cerebrum, sometimes it is also referred to as medulla of the cerebrum, as the grey matter which is located more outside would be called cortex of the cerebrum, cerebral cortex, and then the white matter, cerebral medulla. But then to avoid repetition of the term and confusion between medulla oblongata which sometimes we also call medulla only. So we avoid using the term as white matter or as medulla of the cerebrum. Instead, we're just going to call it white matter of the cerebrum. What is in the white matter? These are the axons, mainly with myelinated or myelinated axons, which gives white appearance to that area. Now let's look at the ventral aspect of that particular region. The part where which I'm touching with the probe now. Matthew, if you can focus a little bit more on this area. So if you look at this region closely, here we see intermixing of the white matter and grey matter, and that is what your internal capsule is. Remember, it's not going to be present only in this region, it's going to be extended slightly more caudal. And so on the medial side of the internal capsule, we have the major basal nuclei, or one of the major basal nucleus, that is the caudate nucleus. The same one that we observed when we looked at the hippocampus is now located right here. Okay, the space that we see on the medial side of the caudate nucleus, that is the lateral ventricle. I can see now the sagittal section. I am still going into the lateral ventricle. Okay, so that is all your lateral ventricle. But remember, the lateral ventricle on this side and lateral ventricle on the other side, they are not connected to each other. What separates the lateral ventricles from each other? Septum pellucidum, which is going to be septum between the corpus callosum and the fornix, which separates both of these ventricles from each other. Okay, so here we saw the internal capsule. As the major nucleus which is present on the medial side is the caudate nucleus, some of the nuclei are present on the lateral side as well. Like the claustrum, that nuclei is present on the lateral side. As we come further backward along with the piriform lobe, then you have another nucleus called amygdala that is also located on the lateral side of the internal capsule. Okay, but at this point, once we understand the location and structure of the internal capsule, that is more important. You can see the gyrus right here, the sulcus, the cruciate sulcus in front. So once you identify those residues, these are the gyri,